Okay, let's graph one more transformation of a log, and then we'll look at some functions and determine what the domain is without graphing them. So to graph the log of x base 4 minus 3, let's start with a basic graph of log of x base 4. So we know we have 1 over b, which would be 1 over 4, negative 1. We have 1, 0, and we have 4, 1. We have an asymptote of x equals 0. Now we'll graph, or come up with the points first, then we'll graph the transformation. And so to subtract 3 from the function, this would cause you to shift, cause the graph to shift down 3 units, which affects the y value. So we're going to subtract 3 from each y. And then we'll leave our x values alone. So the x value is 1/4. If we have negative 1 and we subtract 3, we're going to get negative 4. 1, 0, we'd subtract 3 from 0 and we get negative 3. And 4, 1, we would subtract 3 from 1 and get negative 2. If we have a vertical asymptote, shifting that up and down has no effect on it. So our vertical asymptote is still x equals 0. So 1/4 down 1, 2, 3, 4. Plot our point. Over 1 down 3. Over 4 down 2. Our vertical asymptote is x equals 0. Connect the points with a nice smooth curve and approach that y-axis without hitting it. So if you are, you have to think about what type of transformation, and this will be a question that will come up in the practice, what type of transformation would affect an asymptote for an exponential function as opposed to, or an asymptote for an exponential function as opposed to that of a log function. In this case, we had a vertical shift, and the asymptote was not affected for our log function. All right, now let's look at some domain questions. And what we know is that for a logarithmic function, basic logarithmic function, y equals log base b of x, we know that x has to be greater than 0. And so part of the reason for that, what makes sense, is if we rewrote that in the form of b to the y equals x, by definition, b has to be greater than 0. So if you have a positive number and you raise it to any power, that's not going to change the sign. You have to have a positive value. So that's why x is greater than 0. So for log functions in general, in order to find the domain, what we'll do is just take the argument and set that greater than 0 and solve it. So for this one, log of x minus 2 base 3, x minus 2 has to be greater than 0, therefore x has to be greater than 2. One way to state your domain is using set notation like this, x is greater than 2, or you can use interval notation, and that would be 2 to the infinity, and you'd need that open parenthesis around the 2. Let's look at b. Y equals the natural log of x minus 2. And what this does is this shifts the graph down, but this 2 is not, this is not in parentheses. If that were in parentheses, that would mean something different. That would mean like what we did in part A. But it's not in parentheses, so the argument is actually just the x. So we're going to set x, basically x has to be greater than 0, so our domain is from 0 to infinity. And so shifting a function up and down does not affect a vertical asymptote. All right, C is a little trickier. We want to take our argument, which is x plus 1 squared, and we need that for that to be positive. Well, what we know is that x plus 1 squared is always, it's either positive or it's equal to 0. It can never be negative, because when you square a number, it's always going to either be positive or 0. So what we know is it can never be negative, but we have to think about and get rid of that value that would cause x plus 1 to equal 0. So if I take x plus 1, set it equal to 0, I know that x would equal negative 1. So the only issue, the only value that I'm not allowed to replace x with is negative 1. So I would basically state that x cannot equal negative 1. That's one way to state your domain. For interval notation, it's negative infinity to negative 1, open parentheses, union negative 1 to infinity. And the last one, y equals a negative log of x. This is a reflection. The negative causes a reflection, but it does not change the domain. The argument is still x, and x has to be greater than 0, or in interval notation, your domain is 0 to infinity, not including x. So now I'd like you to pause the video and practice some problems on your own, and then turn the video back on to check your work. Alright, let's graph y equals the log of x minus 2 base 3. First, I want to graph, or at least list the ordered pairs for y equals the log base 3 of x, my x and y. So I'm going to have 1/3 negative 1, 1 0, and 3 negative 1, and an asymptote of x equals 0. For y equals log base 3 of x minus 2, we're going to shift this to the right, so we're going to add 2 to each x. So I have 2 1/3. I'm going to have 1 plus 2, which is 3, and I'm going to have 3 plus 2, which is 5. My y values are not affected. So it should be a positive 1. And since I'm shifting this to the right 2, my new asymptote is going to be x equals 2. So 2 and 1/3 down 1. 3 0, and over 5 up 1. My asymptote is x equals 2. I'll graph that in, and I will draw a smooth curve through these points and approach my asymptote. The next one, graph the y equals the natural log of x minus 3. I first want to graph y equals the natural log of x. So I know it's going to be 1 over e, negative 1, 1 0, and e 1. And my vertical asymptote is x equals 0. Y equals the natural log of x minus 3. I'm going to shift this graph down, so that affects my y values. I'm going to subtract 3 from every y value. So negative 1 minus 3 is negative 4, 0 minus 3 is negative 3, and 1 minus 3 is negative 2. And shifting down does not affect a vertical asymptote. Shifting left or right would. So I'm going to go 1 over 3, which is around 1/3, and down 4. Over 1 down 3. And then over e, which is around 2.7, down 2. My vertical asymptote is the y-axis. And so this is the graph of y equals the natural log of x minus 3. Okay, let's check the next few questions. What type of transformation affects the asymptote of an exponential function? Well, since an exponential function has a horizontal asymptote, then a vertical shift will affect that. A vertical shift of either up or down will affect a horizontal asymptote. And for a logarithmic function, since the asymptote is vertical, then a horizontal shift will affect that, either left or right. Okay. And the last couple here, find the domain of the following. I know that x plus 7 has to be positive. It can't be 0, and it can't be negative, so x is greater than negative 7, or in interval notation that would be negative 7 to infinity, open parentheses on both ends. Here I know that x minus 5 cannot be, x minus 5 squared cannot be equal to 0, cannot be negative. What I do know is that this expression will never be negative. The only issue is what value would cause it to equal 0, and that would be when x minus 5 equals 0. So I want x minus 5 to not equal 0. So basically x cannot equal 5. So one way to state that would be just simply to say the domain is x does not equal to 5, or x cannot equal 5, or in interval notation, negative infinity to negative 5, union negative, that should be positive 5, that's right, positive 5. So negative infinity to 5, union 5 to infinity. That would be excluding the value of 5. Last one is an exponential function, and so the domain of an exponential function is always all real numbers.